Hi and welcome to the video on using indices. By the end of this video, you should be able to write numbers in using index notation and also know what it is, and also how to shorten mathematical sentences. So let's take a look at quick ways to show big numbers. Let's say I wanted to add the number 2 to itself 24 times. Now, I could write out 2 24 times, or it would be a lot easier just to write 24 times 2. 24 times 2 is 48. It's pretty easy to work it out from there. But if I had to add 2 to itself 24 times, it would take a long time. But what about if I wanted to multiply 2 by itself 24 times? Well, that's going to give me a much bigger answer. It's not 24 times 2, it's actually 2 to the power of 24, with a little 24 written up and to the right of the number 2. Now, I want you to take a guess at what you think 2 to the power of 24 is, because it's not 48. It's 16,777,216. And I'll let you work that out for yourself, or you can use a calculator. But index notation allows us to write really large numbers in a shorter way. Let's take the next example. 8 times 8 times 8 times 8 times 8. I'm going to multiply 8 by itself 5 times. And a shorter way of writing that is 8 to the power of 5, with an 8 with a little 5 up and to the right. Now I'm going to show you some language now that has to do with index notation. For example, that 8 to the power of 5, that 8 is called the base. Oh, and the answer is 32,768, but we'll get to that in a second. The 8 we call the base. That is the number that we are multiplying by itself 5 times. This is not 8 times 5. This is 8 times 8, which is 64, times 8, times 8, times 8, and that's how you get up to 32,000. Now that 5 we call the index. There are other names for the index, like power or exponent if you really want to get fancy, but we're going to use these words to describe the number of times that we are multiplying the base by itself. Now that 32,768, that might be the answer, but we also call it the basic numeral. That is the answer without any powers written in it. We can also call it the answer as well. Now, when we write out a mathematical sentence like this, 8 times 8 times 8 times 8 times 8 equals 8 to the power of 5, we call that first part the expanded form. It is the number 8 written out in a long way 5 times. Could you imagine if it was 8 to the power of 50 or 100 or 1,000? Not only would the answer be astronomical, but it'd also take a very long time to write it. It's a lot easier writing it in index form. And that's what we call that answer 8 to the power of 5. And sometimes we want you to be able to write in both ways, because the expanded form shows understanding and the index form shows that you know how to write it in a much shorter way. Alright, let's get to some examples. I want to write the following sentences using index form. That means to write them with a power. Now the goal of this is to not find the answer. I don't want to know what the answer is. I want to know how to write this in a shorter way using index form. Now let's start with 9 times 9 times 9. That is 9 being multiplied by itself 3 times. So that is 9 to the power of 3. It's a much shorter way. I only use 2 digits, the 9 and the 3. And I'm not writing 9 times 3. This is not 27. 9 to the power of 3 is actually, as I type it into my calculator, 729. But I don't want to have to work that out every time. I can just write it as 9 to the power of 3. Now this second sentence uses different bases. It uses 2's and 3's, and I can't just combine them all together. So here's what I'm going to do. I'll start with the 2 times 2 times 2. That's 2 to the power of 3. Then I'm going to multiply it by 3 times 3. And I can write that in a shorter way, 3 squared, or 3 to the power of 2. That is the answer in index form. I don't need to know what the actual answer is. I don't need to know that it's 72. I just want to write it in index form. All right. Let's go back the other way. That's index form. Now we want to talk about expanded form. So here I have two questions that are in index form at the moment, 4 to the power of 5 and 3 to the power of 4 plus 2 to the power of 2. What I want to do is I want to write them longer, in a longer way, to show understanding. Well, 4 to the power of 5 does not mean 4 times 5. It means 4 times 4 times 4 times 4 times 4, doing it 5 times. That's it. I don't want to know the answer. I just want to write it in expanded form. The second question has a plus in it, and it also uses 2 bases. That 3 to the power of 4 needs to be 3 multiplied by itself 4 times. Then I've got the plus, then I've got 2 multiplied by itself twice. I don't need to know the answer. That's expanded form. That's all I need to know. finally, we want to evaluate 7 squared, take away 6 squared, or 7 to the power of 2 minus 6 to the power of 2. Now, evaluate actually does mean find the value. You can see the word value there in the actual word. So we're going to find what the answer is. So 7 squared means 7 times 7, and 6 squared means 6 times 6. That is what we're going to be taking away. 7 times 7 is 49, and 6 times 6 is 36. That's the subtraction. And so 49 take away 36 is 13. I have evaluated the index. So what should you write? Well, a heading called using indices, as well as the basics of what powers are, as well as what index form and index form is a very good start. And then you can write out the 3 examples or 3 sets of examples that I gave you. Pause the video, go back and write them now. Okay, that's it. Hopefully now you know how to use index notation to shorten mathematical sentence and also how to expand it out as well. As always, if you have any questions, ask me tomorrow in class, and good luck.